Can you see it? Yeah, this is much better actually than my laptop. So again, I'm Pankaj. I work here at Staples, cloud engineer. And basically, that is my Twitter handle, my GitHub handle, my Docker Hub handle. So anything that I'll be showing right now here, you can find it on that handle. Just search Google with that ID, you'll find stuff. Ajay, he's my colleague. He'll be helping me with slides and some presentation here. This is the thing that we are going to do in demo. How many of you have heard about Kubernetes? Everybody. This is such a nice audience. Huh? This is really good. So, first question. It'll be interactive one. So generally, it's like the audience asks me questions. Rather, I go the opposite way. I ask questions. And if you have the answers, we just skip the slide. Kubernetes, K8. Why is it called K8?
I don't know, actually.
So most of the time, you'll hear like people saying like it's K8s and things like that. Like Golang, there's a history between somebody says Go and then Golang. K8s and K8. So started like Kubernetes. It's a really tough thing to pronounce. My name is pretty simple. It's Pankaj. People have called me Pancake. So so you can think how they will pronounce Kubernetes. So it was a lot. People used to say Kubernetes, this, that, and then they said like, hey, we will just squeeze it down, K8s. Between Kubernetes, K and S, there are 8 characters. So they made it simple, K8s. So 8 characters between K and S. So what actually is Kubernetes? So you can read the slides here. This is the thing. So this is a Golang meetup. Why are we doing Kubernetes? Why I was interested to do Kubernetes here. I'm a sysadmin. I do a lot of Python. I started playing with Kubernetes like a year and a half ago. And then I came to know, like, hey, this awesome thing is written in Go completely. That's what drove me towards Go, and then I started learning Go and doing Go. Because if you're playing with an open source product, you've got to know the language so that you can open up the source code file and see what exactly people have done. How many of you know containers here? Okay, so what are containers? So you know what problems does container solve? Like we have all been where you buy physical or you buy Raspberry Pis and you build your data center on Raspberry Pis, or you do your VMs. There are times you have Amazon Cloud, you have Google Cloud, you have now Microsoft Cloud, where you can get VMs, deploy everything. But containers are a little different than that, and let's go into a little bit, basics of what container is trying to solve. If you're all good with containers, we can just skip. Mostly I do ask people if they want to learn more about containers. We'll go for the next 4 or 5 slides, else we'll skip it. So pre-1960, how did shipping industry work? This is how. So just think about this picture. Walk with me. So you had all these different items which needed to be shipped. You had, you'd have coffee. Would you want to ship your coffee along with somebody's piano, side by side? Or somebody shipping this, whatever is this dangerous material here, and your piano or your car by the side of that? You would never do that. So pre-1960, this was the condition. People were like, everybody wanted to ship stuff. There was no standard. There were all these different mechanisms of shipping. You had like, train, this, that. But this was a mess. Even if you think like, if you have to ship all of these things, it was uncontrollable. So in IT world, we have a similar challenge. So we have static websites, user database, queues. You can think of anything right now. How much time does it take for you to go there and write a Go REST API? 3 hours, 4 hours, 5 hours tops?
Depends.
Yeah, so if you have to write a basic microservice, you have some database, REST API, 5 hours, you have written it. Everybody does like that. Then what is the biggest challenge at that time? Now you have written that, okay, fine. This part becomes really easy. But now, you go and talk to any developer, I can write something in 2 hours, but to get this to production, it takes me freaking 3 weeks. Why? Because now I have to first test it on my laptop, it works. Development, QA, public cloud, here, there, it works here, it doesn't work there, things like that. And we all have said this and heard this. Who hasn't said this? If you write code, you have said this at some point in your life.
Works on mobile.
Yeah, I have said that myself, and I've heard it too. So, how did shipping industry fix it? So, it's like, you learn from somebody when somebody does it, something like that. So, shipping industry came up with a really standard thing, like container. If you can fit something in this container, it will ship. And I don't have to worry about what is next to me. In this container, I can fit a car. In the next one, I can put in chemicals, and they can both go side by side without impacting each other. Everything here down, all the, you have ships, factories, trains, everything now they have a standard. Like, this is the length, breadth, height that we have to make equipments for. So moving stuff became really fast. How did it help now? Now everything is standardized, right? What is the key word here? Standardization. You have a standard. This is the container packaging thing. You have a model for packaging. You package things in this, and everything else is a standard. You don't have to worry about it. Same thing. What did in the IT industry came? There was container. So container, Docker, is it the same thing? It's the same thing, right? Everybody says, yeah, it is the same thing. Now, Linux and Red Hat, is it the same thing? No, it's not. It's the same thing here. Container is a technology, and Docker is a company. So Docker is like, as you say, Red Hat is to Linux is same as Docker is to containers. So container has been in the industry for a long time ago. It has been like, if you have done some Sun Solaris and stuff like that, containers was there at that time. But what Docker did, it's presented in a form so that it can be used by, developers, by sysadmin, everybody. Like, it generalized it. So it's the same thing here. If you can build it and put it in a container, you can take it, you can run it anywhere. You can take it, if the container runs on a development VM or your laptop, it is going to run in your data center. It's going to run it in Google Cloud. It's going to run it in Amazon Cloud. And it's the same way it runs. Why does this work? So anytime you see in IT industry, you'll have developers and you'll have ops guys. There was a time when people wanted to mix them together, and it's like make DevOps out of it, and so that you will do development work and you will do ops work. I had a good meme, I didn't put it here. It was like, hey, what do you expect from a DevOps? Oh, you should be able to commit your code, you should be able to review your code, and that's how the boss says. You should be able to deploy your code, and then the guy says, like, do you want me to do your homework too? So it's like expecting that much of a DevOps. So why it works in this industry, why does it work? It's like you're separating the concerns. Well, fine, it's really good to be DevOps, but okay, fine, developer, if you just focus on, developer is going to just worry about what is inside the container. So if I'm a Java developer, if I'm a Go developer, for me, what does matter? Go, environment, that's it. If I say, like, I need to do a Go development, like, he showed everything. In our previous presentation, was there anywhere mentioned that you need to have a MacBook or a Windows book or this VM or that VM or this hardware to run Go? No, Go will run anywhere. You need a Go environment, that's it. So for a developer, he is just concerned about his code, his libraries, his package manager, his apps, his data, that's it. He doesn't have to worry about anything else. What does an ops guy have to worry about? Ops guy has to worry about logging, remote access, monitoring, network config, that's it. Start every container. If you're writing a Go program, your containers will start, stop, restart the same way as somebody else if they are writing Python container or somebody is writing Java container. Just think how much life of ops guy is becoming easy. Now I don't have to know how your Java code works or how your code works, how your Go code works. That is your responsibility. For me, I have to keep it running. If it's running, it's all good. If it's down, okay, fine, it's your code. And so if you see this diagram, Earlier, what used to happen is like you'll have operating system, and then you'll have all VMs stacked on that. Like you'll have one physical hardware, and then you'll have 10 VMs on top of it. How containers changed it is like you have your physical hardware, you have operating system, you have some kind of container engine out there, Docker, and then you can deploy all apps as containers on top of it. Just this diagram shows like you can have same app or multiple versions of app deployed using different version of the same library. A simple example is if you have a physical machine, how many Nginx server or Apache server or a Go REST API server can you run on port 80? One. Can anybody run two? There's no way, right? But that's where container comes up. So if you have to run two services or two of your program on the same machine, how do you do it? That's where what containers will do. Like you package that inside a container, and you say like, hey, my application is always going to run at port 80, and let the system handle. You can say like, start. Now you have 4 instances of things running there, and all are running at port 80 because they have their own user space. Anything above operating system, every application will have its own user space. I don't know if there are 2 more of me running. For me, I get a request, I have to serve it. There may be 5 more or 3 more or 2 more running, and all will be running at 480. That is the core one of the core pieces of Kubernetes. So you have to walk through, like you have to understand what is containers. If you understand containers, then we'll understand something else. There are 4 or 5 things when we understand. Then when we do the demo, you'll be able to understand the demo. It's all linked together. So from here, I'll hand over to Ajay. Ajay to explain to you some more of these pieces.
Thanks, Pankaj.
Mm-hmm.
So Pankaj described how easy is Docker and container, right? So now every developer start writing their application containers, and they say, okay, give the sysadmin guys, okay, just deploy it. Now there are thousands of containers, right? So now how do you manage all these things? So that's where the orchestration engine like Kubernetes comes in picture. So in Kubernetes we have many constructs. So I will start with the pod. So this is a basic Kubernetes. So what pod is in a Kubernetes world, right? It's a so container. The pod is can have multiple containers inside it. And why you want to put multiple containers in a Kubernetes pod? So there's an example here in the screen, right? So I have a web server. So my web server is running in a container. I have a web server which actually serves the content to the client, right? But it also depends on some of the data. It wants to refresh every time. So if I package my web server, the file puller, and the volume within the same construct, which they call it a pod. So Kubernetes manages the pod. Kubernetes doesn't manage the individual container. So that's where the pod construct comes in the Kubernetes picture. So and if you want to access this particular pod in Kubernetes, so you can access it. It's because it shares the same namespace, so you can have the same IP address for all 3 containers inside that, and they can actually be accessed using localhost within the pod construct. So that is one of the advantages of running pods inside using Kubernetes. And with the pod, with Kubernetes orchestration engine, so if this particular pod dies, this is ephemeral. So basically, this pod can die. Kubernetes will actually run it into a different node in Kubernetes world.
So a pod is a small container, a small group of containers.
Right. You can have a one container or a multiple container within, depending on your application, what you're actually running as an application.
What's a large group?
So
A bigger pod.
So usually I see so container is a one process, right? So it depends on your application. Basically, I have seen 2 or 3 within one pod, basically. You can always communicate with other pods if your application depends on, let's say, outside database, right? You can also define your pod, the application system that you can call another application. Pankaj, you want to add something there?
So it's all the world of microservice, right? So what is the minimum thing that you want to that can provide a service? So Yeah, like this, in this example, like, hey, a web server will be a different container. I can just run web server myself. There is a file puller. I can write a Go application which will go to GitHub every 10 minutes, get all the data, dump it on the local drive. You know? And then this volume is nothing but local cache. So that's one service. I'm providing a service. I'm taking some data and giving you refreshed every 30 minutes. That's one service. But I want to couple it together. Why? Because anytime if this system goes down and I want to start it somewhere else, I just don't want to restart Nginx. That, hey, Nginx start here and my caching thing is here and every time it has to go. I want the caching system to be as close to my Nginx container as possible. So what I do is I put them in a pod, 3 containers together.
Yes.
The advantage, all of them, they can now talk at localhost. So what they share is a network namespace. So there's 3 containers, they can talk at 127.0.0.1. That is the key part. So anytime file pull up, like I build the cache, I have to give cache to somebody. I need to know where is the caching system. But in this one, I don't need to know the caching system. I know the caching system is at 127.0.0.1. When my web server has to pull some data out of the cache, I don't have to know that, hey, it should be cache.staples.com or cache.something. No. I know it's at 127.0.0.1. If it dies, if this thing dies, the hardware below this dies, what Kubernetes platform is going to do, it's going to take all of these 3 and spin it somewhere else, so that your cache and everything gets refreshed fast. So it's just, pod is, you can see here, you can read all of this. It's an atom, like it's an atom of cluster scheduling. So when I have to schedule something in the cluster, what is the basic unit that I'm going to move around? And that's pod. Yeah.
So the pod is a pod the equivalent of a Docker Compose?
In a Docker Compose file, when you do that, yeah, that'll be a pod. Yeah, you guys use Docker Swarm? Anybody playing with Docker Swarm? If you do Docker Swarm, then Docker Compose, it's one-to-one kind of thing. Yep.
Does the notion of container of containers make any sense?
It's container of containers. It mostly goes into like Google Cloud. In Google Cloud, you go there and say, like, hey, give me a VM. That VM is actually a container in Google terms. So when you say, give me a VM, Google is going to give you a container. And then you can run container inside it. And you can run Kubernetes inside it. So it's like you're running a container by asking a VM, which is actually a container, which manages all your other containers. So it's that kind of construct.
Everything in Google runs container, by the way.
Yeah.
They don't.
Right.
So another one is a label. So when we think about the label, right, we decide if this is a name, so what's the name of this particular thing and what it contains. So label is a basic construct in Kubernetes where you can actually, it's basically a key value pair, and it's stored in the etcd database in a Kubernetes masters. There's an etcd cluster. So when you construct the whole Kubernetes masters, there is a etcd cluster you can define for the highly available cluster. That's where the key value pair is stored for the labels. So as you can see in the picture, so here there are 4 pods shows in the picture, right? How do you identify the pods? It's by by the label. So on the leftmost, app is equal to nifty, face is equal to def, and role is equal to fp. Those are the labels for that particular pod. That's how you identify your labels. So this is another important aspect of Kubernetes where you define your pod. When you define it, you can define using the labels. Yeah, it's basically user identified attributes, right? So you want to add something here?
You have to understand labels really good. So everything now we are talking about building blocks. We talked about containers, then we went pods, then we are going labels. So you have to understand each one of these to understand the demo. So any questions on labels?
The labels are just that's a way of characterizing a pod.
What's your name?
Yeah, that's a label.
So it's like, what's your name? Name X. That's a label. So name is the key, and name is there. Company X. So when you have like all these people who are working here, how do you categorize? Company Staples. Oh, there are these 4 people. Company Y, there are these 2 people. So labels is just a key value pair that you can assign to anything. So if I'm running a pod, I'll say like, hey, I'm going to write uh, a pod which will be part of an application. So an application will be part of multiple microservices. So I can say like, hey, that app is Nifty. I'm going to write a Nifty app, and this is the role of this container is front end. I can have another role as BE, like back end. So this is my front end, this is my back end, but they are all part of the same app Nifty. So these are all just labels. Labels will become more clear when we go to the next step. But right now, just understand, labels is something, key value pair, you can give anything to a pod. Again, to a pod, not to a container.
So now we learned about labels, right? This another very important is selector. So selectors and labels go hand in hand, right? So if you look at on the screen, right? So app equals Nifty, which selects all the 4 ports together because everyone has a label called app equals Nifty. But when you drill it down, right, on the leftmost side, as shown in the last slide, right, that's the face dev role is the front end. This is a different thing. So that is a differentiation between different labels. But when you look at the right side, if you want to actually, it's a subset of the things, right? So on this side, if you say app equals Nifty, face equals dev, then you are actually addressing those couple of ports together. So roles, so the labels and selectors go in hand, and when you go to the next slide, it will better understand why and how it is being used in the Kubernetes structure.
Any questions on this? This is pretty simple,
pretty
right?
simple.
Yeah.
The application
Yep. This is, yeah, replication.
So Kubernetes has another thing called replication controller. The job of the replication controller, so we tell the replication controller that I want my 4 pods running all the times. So the role of the replication controller is to observe, right? So it observes it. How many pods are currently running? Then it checks with it checks if I was told that I have to keep 4 pods running all the times, and if it checks if there are three pods running at the time, it will act on it. What it will act on it is run that particular pod to another node, Kubernetes nodes. So basically, application controller makes sure that if you say, if you look at this YAML definition of replication controller, when you define the replication controller, that says this is my name is Nifty replication controller, right? Nifty-RC. This is a selector, which we just talked about it. Selector say, okay, I want to act on app Nifty, face dev, and role front end. So it knows which pods runs this, which pods has this label, and it looks for those, and it's a number of replicas. It says a 4. So it makes sure that any time there should be 4 pods running for this particular selector, basically. So replication controller is another aspect. So basically is something happened to a node, right, where your pod is running, node died. Application controller will make sure it will tell scheduler and it will spin up another pod.
I understand name selector and number of replicas. Pod template's confusing me a little bit.
Oh, so forget about pod
Yeah.
template right now.
That's-
This is where you define how your pod looks like. So you just understand these 3 things. So you say Nifty this. Inside of this is a nested YAML. So this example is from nested YAML. Inside of this, you'll say like, hey, this pod consists of these 3 containers. This is where the pod configuration goes.
Okay.
So you have containers, you have pods, you have replication controllers. Walk with me. You have to take each step, understand each. So inside of this, we will be defining pod, which will contain all the containers. And then you will be defining this replication controller on top of it to manage that pod.
Okay.
So if something happens to your application in the middle of the night today, how many of you just leave it for SRE to handle it? Or somebody to wake up in the middle of the night not to be woken up? Everybody, right? Nobody wants to wake up in the middle of the night. We will solve that problem.
So pod, labels, selectors, and replication controller. 4 things, right? We just talked about. So this is just showing you. So it's more visualization, right? So it just says wizard is 4, current is 4. This is what I'm going to look at all the time. There are 4 running, and then next to the next slide, something happened to one of the
Zap.
parts, right? It's gone. So what is replication controller is going to do? Replication controller is going to run that. It says checks it. If its current is 3, it's going to spawn up to another one. So right now you only have 3 nodes running. Earlier in the picture there were 4 physical nodes we were showing. Just like this we were going to show in the demo, right?
Yeah.
There are 4 things to run, 4 physical Raspberry Pi clusters there. but one is died. So the scheduler will check based on where best to run that particular pod, because it can place this particular pod which just died to any of the node, right? But it just checks that it best find the best place for it to go, and it will start that particular pod into that particular node.
Any questions on replication controllers? Cool.
So the logical conclusion is that you could lose 2 more nodes, and all 4 pods would run on 1 node.
Potentially, yes. Depending on how when you define a pod, you also define how much memory, how much CPU you want to run it with.
Yeah.
So, if there is resources available, yes, it will run like that.
But the concept is right.
Right.
Yeah.
So now we define label, selectors, replication controller. How does the people outside of that particular Kubernetes cluster access your particular pods, or whatever you define your application? How are you going to access your application from outside of that? So that's where the services come into picture. So services is another definition. Is the similar like in the YAML format or JSON format. Is the YAML format, right? It defines what my service looks like. It just says that my name is this. Now selector is another selector coming, right? Now we are, as a whole, if you look in the previous slides, we have a role as a back-end, role as a front-end kind of thing. But here we're just defining this, my service app is nifty. So it works on that particular selector. So it basically selects everything what we showed in the last screen, right? It tells that I want to run my services on port number 9376. So outside, when you come into the Kubernetes cluster, you want to access this particular service, you can actually access on that particular port. But inside the Kubernetes cluster, the containers, all the containers run on the same port, like 8080. On all the nodes, they run on the same port, 8080. So it's a Kubernetes which will allow outside folks to access your service on that particular 937. They don't have to know anything else, where your container is running, where your port is running. They just come in with that particular service name and the port number, and you will be directed to that particular service.
So this is managed by the Kubernetes manager, right? Or Kubernetes.
Yep.
If that, is that a single point of failure?
What?
The Kubernetes manager that.
Oh no, you can have
API
three.
servers,
Yeah.
3 API servers running as a cluster.
You have all these nodes, and then you have the master, right? You can have 3 masters.
And so when you're accessing these ports, for instance, is it from you hit that Kubernetes?
You can hit any node.
Any API server.
So here it's like 4 nodes. If one goes down, generally what you do, you will put a load balancer or something F5 kind of device in front of it, and when it goes, it will load balance across all of them. So you can say like, hey, go there. If my pod is running on node number 2, but somewhere I go and hit at this port, like port 9376 on node number 3. So it's random, right? Load balancing, I can go on any one of the node. If I go to node number 3 on port 9376, Kubernetes internally will redirect me to node number 2 on port 8080. There is kubeproxy running there. So we are going into details. I'll show you a diagram after this, but that is like, hey, internally it will handle. You don't have to worry about it. Your pod can be running anywhere in the system. You know this IP. You can go on any IP, any port on that particular port, and it will give you the data.
Okay, this is just a slide just to put all together in one slide, right? We talked about replication controller, pod, and the services. So basically, as mentioned, service, we are label selecting the role as front end. Both the pods running are role as a front end. They have a version 1. And the replication controller is asked to work on the ports, number of the ports, where the label, where the selector is role FE and version 1, number of the ports is 2. So it makes sure that every time the 2 pods should be, 2 replicas should be running at any given point of time.
So this is where all labels and selector make sense. Does it not? Still there is confusion in here. So on the pod side, you give labels, version v1, role front end, version v1, role front end. That is the atomic unit of deployment. You deploy a pod. When you deploy a pod, you give labels along with it. You give label version v1 and role front end. Now, you want 2 copies of this running all the time. What you do, you create a replication controller. Now, replication controller does not know what to manage, so you put a selector. Selector based on labels that you put in step number 1. What are the labels that you put? You put version v1 and role front end. You are specifying it here. This is my selector. Like, hey, always in the entire cluster, keep 2 pods running which has got the label role front end and version v1. So this part, it always keeps that running. The next part, now you want users to access your service. What good is a user, is an application if it's running in the basement? So you want to expose it to the outside world. There is where you create a service. And this, when you create a service, you have to say like, hey, what is the role? Role would be front end. So whenever a user comes in, it is going to take that connection, reverse proxy it to any one of these pods. Any one of the pods which has got a label front end. The label you gave in step number 1. So that's all how it ties out. Questions?
So the replication controller spec role version number of pods constrains each of the pods that are in that controller, so that you couldn't have, for example, a version v1 and a version v2. They must be v1.
Under that replication controller's control, but you can define another replication controller
Yeah.
which can have.
You're understanding perfectly, and that's the next slide. That's totally the next slide. How many of you have heard about Canary? Canary, everybody wants to do Canary releases these days, zero downtime releases, stuff like that. This is how you do it. Now, this is where your answer to your question comes in. Go ahead.
I think this is self-explanatory, but this is still your service. You're saying that I want, the label selector is still a role front end, right? But my 2 replication controller in the picture. One is acting only on version 1, and it makes sure that 2 pods are running at the same time. But we have another replication controller which has a version 2, right? But outside client doesn't know what's going in behind the scene, right? When the traffic comes to the service, hits the service, it's going to send the traffic round robin to one of these pods. So if you want to release something, let's say you have 100 pods running for your main application version 1, you want to release it to another version 2, but just you want to see that only 10% of your traffic goes there, you can spin up another application controller with 10 ports under that control with 90 that version 1 and 10 is version 2. You can have a 10% of traffic goes to your version 2 because all traffic is far away from the service. You hit the service and it just rounds robins to their backend ports.
So question here, if I hit this service here, what is the probability that I will get version 2 of the application? You guys are not asking questions, so I'll ask rather.
1 out of 3.
2 out of 3.
There you go. So you can see here on service, what the label selector is only role equals front end. And you can see all of these 3, even version 1 and version 2, have the same role. So service is going to split the traffic between all 3, but we have 2 separate replication controllers. One which is maintaining the version 1, 2 copies, and one which is maintaining version 2, only 1 copy. So if version 2 goes down, it will spin 1 copy somewhere else. So that's how you define your environment, so that it never goes down. Once you can check logs for version 2. When version 2 looks good, you can convert all of them to version 2. So
you hit the service at the port you defined,
yeah.
and the Kubernetes master will decide which pod to give it on that port that is
Yes.
going to the service.
Right. Okay. And then so this is 50,000 feet of Kubernetes architecture. We have all talked about it. So you have one master. I believe you'll have this as an HA, so you'll have multiple of these masters so that they'll be talking to each other. Even one master goes down, another is live, but you'll have a master. And then you have these minions. Earlier they used to call them minions, now they call them nodes. You can call them worker nodes, but this is where your actual load runs. So master is the one which controls everything, and you'll have, like here you have Docker, it'll have some kind of container engine running. We run Docker here. So it will be, master will say like, hey, you pods run here, this goes down, I'm going to go here. all that decision master is going to take. So this is from 50,000 feet. If you want to go in detail how actual what all processes are there in Kubernetes, how they talk to each other, this is the one. I'll put the slides. I'll give you the PDF of this, but I'm not going to explain this. If I explain this is a full day class. But okay, now the most interesting time, demo.
Well, I have a question before
Yeah.
we get to this. Going back to that high-level architecture,
Mhm.
I mean, I'm struck by the fact that the real dilemma here is, how does one decide how many pods, how many minions, and probably how many masters? I mean, there's a lot of moving parts there.
So, masters, there is no dilemma. 3 masters. That is the minimum you need for a cluster, for a HA cluster. You need 3 masters.
Okay.
You put 3 masters here so that, if one is down, 2 can negotiate like, hey, I'm going to be the next master and stuff like that, and the other 2 are just listening and synchronizing stuff. Minions, here is like when you define your application. So when you define your application, you test it on your laptop. You're testing on your Mac, and you say like, hey, I'm going to my one application works really good when I'm serving like 100 customers or 100 connections. So what you define is like, hey, I'm going to make a pod of my container and put the container there, put a pod, and set like, hey, one pod can serve 100 connections, right? You deploy it, you give it to the master. Middle of the day, your connection bumps to 1,000. How many pods you need at that time? 10. Master is automatically going to decide like, hey, he gave me a pod for 100 customers or 100 connections. Now I have 1,000. I'm going to make 10 of those. You're going to set an upper limit. You're not going to have some DDoS attack come and then you're going to spin like 5,000 and consume the entire data center. So when you deploy this, you're going to put that into a YAML format or in a JSON format. Like, hey, this is my pod. One pod serves 100 connections. You can go maximum of 50 pods and minimum of 2. So even if you have 0 connections, system will always keep 2 of your pods running. But when your load comes in, it will spin up maximum of 50. The next question, so now you're not worried about how many pods and stuff you want. The thing is, how many minions do you want? So if you're running some sort of private cloud in your organization, or you are on Amazon cloud, or you're on Google cloud, what master does is like, hey, I have run all of this and all of my hosts are running 80%. Or these 2 went down. I have just 1 remaining here. What do I do? If you're running a cloud environment, master itself goes and talks back to the cloud and says like, hey, I have lost 60% of my capacity. I need you to create 60% more. So it will spin up 3-4 more systems out there and attach it to master. So you never go ahead and fix systems here. So if this pod goes down, you don't go and fix it. It's gone. It'll spin up somewhere else. If your minion goes down here, you don't fix it. Master will talk to cloud and spin up a new minion. This is gone. Everything is ephemeral. It's like what is the example? Everybody talks about pets and cattle and fleas. So this comes in the fleas category. You don't worry about that. So yeah, go ahead.
The minions are systems.
Yes.
And what do you have to have running on the systems to have that access? So it just access all that raw data of Docker?
Yeah, you need to have Docker here, and then again,
proxy and other.
yeah, so you'll have to go into a little detail if you want. Like, hey, this is how the master talks. You need to have a kubelet here, cAdvisor here, proxy here, and then all these pieces, cAdvisor. Then Heapster will talk to cAdvisor, think how many connection is going. So this goes into a lot of detail here. But overall, you have to understand that in this, you set this up once, and then if you have everything working fine, you don't have to go back there and look into it. And I've seen slides from Google where they say they have, in their data center, they spin up and down around 2 billion containers, I think it was per week. 2 billion containers spin up, come down, where what is running, nobody worries. Everything, Gmail, Google, everything that you type, google.com, gmail.com, calendar, anything you do, it's running in a container somewhere.
And Pokemon Go actually runs on
Oh, yeah.
Kubernetes as well. So it's if you need a success story to sell, right there's
Yeah.
probably
You should definitely, if you were interested, you should definitely see that, because there they have really said they had done a very extensive capacity exercise before that, and within a couple of hours they realized that the capacity exercise they did, they are going to beat that in less than a day. That's when they went back to Google and said, like, because they were running in Google Cloud, like, hey, we need your help. And Google SRE jumped on their product. And they went from what? You should get to see their graph. I'd love to buy stocks with that graph.
yeah. So if you do a search for Pokemon Go and Kubernetes, there's an actual whole blog post about it. So you can actually follow a very detailed, from the launch to today. And like he said, it has all kinds of crazy charts on it. So it's really impressive.
So demo time. If you're done with questions, I'm interested in that. So this is a 4 Raspberry Pi 3 that I have. Again, the same concept, master and worker. I've got the top one is the master, and these 3 are the worker. And I've already configured stuff into this, and I will show you some visualization. You want to take it, Ajay? Come here.
You can explain. I can just type it commands.
Yeah. Yes. So,
Do we have that?
so we have a little visualization too. So this is a visualization that we wrote, just JavaScript, which is using Kubernetes APIs to actually show you what's happening. Ideally, mostly, if somebody says like, hey, your pods are moving, it's running somewhere, you don't have to worry about it. And you go to somebody and say like, hey, this is my application. The first thing they'll ask you, what is your visual diagram for your architecture or for your application? That's the minimum thing that is needed, right? Hey, this is my web server, this is my app server, this is how connections work and stuff like that. Until unless you give your visual diagram to somebody, nobody will understand your application. So this is an effort just to make everybody understand easily what Kubernetes does. 4-node cluster, everything is green. It's a go. Let's go.
So there are 4 Raspberry Pi there, right?
So
So
these
we're
are
gonna
all
create a-
application definitions. So if you see here, these are the files. Let's increase the font. Control plus plus. Control. Come on. Plus, plus. Yeah. This is good, right? Yeah.
So I can show you one of the files,
Yeah.
which I'm going to spin off it. It just defines this particular pod, right? So this is an application controller kind, and it's going to spin up this from this image. It's going to pull up the Docker image and run this pod.
So the second part where you see a spec, the pod template that you're asking about, this is where in the same file I have said like, hey, you have to run this as a replication controller, but this is the container image that you have to run, right? So I could make this like separate files, like one for pod, one for replication controller, stuff like that. But mostly like, hey, I'm going to use this same file everywhere, and I have to modify it. It's going to be in source control. I'm going to just going to put it here.
Is the container image a Docker image?
Yeah. If you are interested in this Docker images or these files, everything is on my GitHub account.
So I just ran the command and just created a replication controller called Nginx. Right now, we already told that only maintain 1 copy of that replica. So just one copy of that's going on right now.
This is your replication controller. This is the replication controller here, and this is my pod running here. So replication controller. Now everything that we have learned in the previous slides, everything will come live here.
You want to do the canary second?
Of service.
Service.
So we deployed the pod there, but would you be able to access Nginx?
Service.
There you go. Yes. So what does it need to create now? So that green part is the service. So a service is created, which is linked to this pod. And if you go to that, yeah, it should give you, if you refresh that, yeah, welcome to Nginx. It's a simple static page. Data. But the next piece would be where now we have to do Canary. We have got version 2, right? So but we don't want to take our site down. We want to see like, hey, version 1, version 2, both works, not. So
We're going to
you
deploy
don't have to
Canary.
go to different people and release engineering like, hey, do this. You just create a new Canary JSON, simple file, just change your pod spec, and that you just put like version 2.0, and just tell it to create a new replication controller. What it did, it created a new replication controller for you. You see the version number here. This is version 1. What's the version for that one? That is version 2. It is the same service, but to different replication controller. Now, if you go to that site, you should rotate between 2.0, 1.0, 2.0, 1.0.
Sorry. Just going to go to 1.0.
Yeah, sometimes it doesn't, so you have to do like a couple of times, refresh.
Yep.
So it'll rotate between like 2.0, 1.0. If say 1.1, it's like 50-50 chances, so it's really difficult to see. But you have like 10 version 1 running, 1 version 2 running. It's really easy to see the difference at that time.
So what is the next thing we're running? Scaling? I want
Yeah,
to scale it up?
let's delete the Canary one to clean up the screen. And everything that he's typing here can be accessed through REST API. So Kubernetes has got a REST API, you can do everything. So mostly, Kubernetes talks everything on REST API and exposes everything on REST API. So if you have a different tool which you want to use to do all of these things, you can just consume the REST API. And once you are done with Canary, it's pretty simple. Like you say like, hey, delete Canary, it's gone. Now you have only one. Version 2 didn't work out. There was a big bug. Nobody needs to wake up in the middle of the night. Just delete it.
So now let's scale it, right?
Now the scenario here is you have one pod, and your
Thanksgiving.
question: how many pods should it be running? Right? Thanksgiving, you have like huge traffic now. You want 4 times the compute capacity for the application. Suddenly, you have started selling things in a crazy way. Now you have to scale it. So what you do is you just do like, hey, scale.sh4. Let's go to that page, and then you can say it's spun up. The beauty is each of these containers spins up in the same way. Going back to our first slide, it's all the standardization that matters. Every container, all of this Nginx, your application starts on port 80, serves data on port 80, starts with the same command, stops with the same command. There is nothing difference between this pod and another pod. All of them have same configuration inside of it. How many times you have had that in production in your company, where you have like 10 system in one application and all have pretty neat same configuration, even if you are doing some configuration management. We don't. So what do we have on the screen? We have a replication controller. We have 4 pods running, and on which nodes are those pods running? So if you see, we have got 4-node cluster, .10, .11, .12, .13. You see this pod, all are version 1. It is running on .11. Is it even visible? Or we on the screen? Is it click on Command
Yeah.
Plus? Is it any better now? Oh, too much. Is it better now? Yeah. So we can see here, like, this is running on 11, this is running on 10, this is running on 13, this is running on 12.
So
So
that corresponds to each one of these.
each one of
Okay.
these, yes.
Yeah.
So you can
So
see,
where is Nginx running, and where's Nginx?
Everywhere, all
yeah,
4.
This is
All
all
four
four
Nginx.
Nginx.
Oh, that's right, and that's embedded into each one of them.
That is a pod.
Ah.
Your pod serves Nginx. So
Got it.
And that is just the service endpoint. Those are all constructs, Kubernetes constructs. Those are class definitions. If you're doing programming, those are just class definitions. These are real objects where your container is running. Those are just sending your data like, hey, you're connecting to that Nginx and it says like, hey, I'm going to send it to one of these pods, which is actually serving traffic. And on the top, when you see like .10, .11, those 4 are actual nodes, these 4 nodes. So at this time, before I confuse you more, I'll need a volunteer to break this cluster. But not as in break the cluster, not the Raspberry Pis. So anybody, yeah, come on. Don't be shy. Oh yeah, yeah, come on. You can just take out, yeah. So what we'll do is, just the hardware
Take a
failure in the
picture
middle of the night.
Don't do it before I take a picture.
Right? Yeah. So one of these things, yeah, you can just plug it out. Now you can see what happens there. So you take the cable out, and please refresh and work.
Okay, good.
Yeah, good. It went down. Cool. Now by .12, you had 25% capacity running on .12. What did it happen? Middle of the night. Did you wake somebody up?
No.
So the thing which was running on .12 with red, your replication controller, how many I have to keep running? 4. There was only 3 available. What it did, it took one and spun up another on .13. So now you have, still, what is your end goal needed? You want 4 of your application, 4 copies of your application running all the time, right?
Is that replication control running across all 4 nodes?
No, replication controller just watches. There is just one replication controller running, and it just watches like, hey, you gave me this selector, like app equals nginx, copies 4. Every, X amount of time it goes in. How many copies running? How many copies running? Oops, not running. I'm going to. Then it doesn't do anything. It says like, hey, there is only 3 running, should be 4 running. It takes that information, passes that to a scheduler. So it's all microservice based, right? Replication controller will do only one task, and it will do it good. It's like, I'm just going to watch this selector. If there is any difference, I'm going to tell a scheduler like, hey, only 3 running, you have to run 1 more. And then a scheduler does just one thing and does it good. It's like, hey, I have to run Nginx. I'm going to find the best place where I can fit in. So it's all microservices based.
But it's running on each of the nodes.
Replication controller?
Yes.
No, it's running in the master.
So it
Why
just
is it? I don't understand the picture then.
It is connecting here because it is watching all of these 3, all the 4.
It's
So
running on the master.
yeah, and it is just watching all these 4 containers.
What's the IP of the master?
.10.
Gotcha.
That's why I didn't tell you to take this out because this is master. And I don't have a HA master.
So the master is also a.
So a minion, I node.
Yeah.
Yes.
Yeah.
Okay. Got it. That's where I was.
So
confused.
it is like you need at least 4 to show something, right? So maybe
All right.
next time I can add 3, 4 more Raspberry Pis on this stuff.
Need a wheel going.
Yeah. So
So,
What
right now, you have 3 connected in right now. So it added in that 4th, but it said, hey, somewhere in these 3 connections, I need to add in a 4th.
yes.
And hopefully you have enough resources.
No, it does. There is in master. If you go diagram, there is C advisors running on each of these systems. C advisor keeps collecting metrics of the system itself and passing up to the master. There's a heapster module which collects all that and correlates. And then when a scheduling is going to go, scheduling asks like, hey, I need something to run 200 megs of RAM and 2% CPU, which is the best place? And then it says like, hey, out of these 3 nodes, this has the most capacity. I'm going to push it there. It does a lot of calculation. How much is the CPU usage? How much is the memory usage? How much network bandwidth is that system serving? So it finds the least used and pushes it there.
So
And
I thought you plug it back in and it came back online. Will it say like, okay, there's nothing?
No, so that is not a good idea. If you read anywhere about cluster management, rebasing clusters is not a good idea. Because even if it came up, you don't know it's good or not, right? So only right now Kubernetes just checks like, hey, okay, fine, that agent is up. when it has to reschedule something, if something is not broken, why I'm going to fix it? So none of these pods are giving me any problems. Why am I supposed to take any one of these down and put it somewhere else?
So the one that just came back online is basically there for future growth.
Yes. So you have capacity. Now we'll...
Yeah, I'll just go to fifth, right? I'm going to turn on one more. So it's going to put it into there.
So now we need 5.
Minus 5. So
Fifth. Where should it put the 5th one?
the one which was died.
Because at that time it calculated every node has got 1 or 2. I have this one piece, nothing running on it. I'm going to put it there.
And so
Technically, we don't know that it's on that new one.
Oh no, we know that.
12 came back from the live, right? So 12 is the one we just
No,
pulled it
yeah.
out, and it
Okay.
came back on the
12
live,
back,
so that's the
and
new
it
one.
came on that 12. So what this is showing
Oh, I
is, this
see
is
the
showing you the
document.
pod name,
Okay.
the version of the Nginx running, and on which physical host it is running.
so the containers your pod can run on your containers can run on anything that can run a Docker container.
Right. VM.
Take a Raspberry
Yeah.
Pi 0 or 2 or a 1.
Oh yeah, I know where you're going. You can build on Raspberry Pi 0, yes.
So you can, the configuration changes would only be installing whatever underlying thing would be for the platform and then connecting that to a master.
The minimum thing that is required to run your Kubernetes is you need to have kernel 3.1 something and a Docker container platform. You can run Docker, you can run Rocket, you can run, there is a new thing which has come, don't know about that. But if you don't like Docker, you can put Rocket on top of it. You can have 2 running on Rocket, 1 running on container. Kubernetes totally abstracts that. So when you put nodes, you can say like, hey, these are my 4 nodes which have SSD and GPUs and stuff like that. Only people who are supposed to put data science workload should go there. So if I'm going to put something in my container with app equals data science, it will automatically deploy it on one of those 3 systems. It is not going to deploy anywhere because I'm going to use GPUs and only that is available. You can play labels and selectors. That's how you play with the entire cluster. You just keep changing labels and cluster and everything else. Container is going to, Kubernetes system is going to manage for you.
And so when you were saying that about the bare metal, what would run on the bare metal? Would it be the
Linux, anything which gives you a kernel more than 3.1. So any version of Linux and a container engine. That's it. So, yeah, go for the next thing. That is the most interesting part of the demo.
You want to do what? Next one.
Rolling update.
Rolling up.
So yeah, version 1. Now you have tested your version 2 with Canary, 50% traffic. Everything looks good. Now you want to update it. Now, are you going to take a window of downtime in midnight from 1 a.m. to 5 a.m. and have 5 really poor people work on that? No. You do rolling updates. Yes.
Let's do the rolling update.
And you just tell like, hey, change all my version 1 to version 2, but don't take the site down. And between every update, keep 5 seconds or 2 seconds. You can say like, hey, this is the amount of time. Why? It's not working. It should. Yeah, it'll work.
these scripts that you're running? Are they
These are just commands.
Commands.
Technical commands. We have just put that into a script file.
I'm just curious if you publish that anywhere?
GitHub. It'll all be there on GitHub. So what Kubernetes is going to do is it creates a temporary replication controller, and then it puts 1.2.0 into the mix, takes 1.0 out. And it'll keep doing that until all 1.0 is gone and 2.0 is there. So now here you have like 3.2.0, it is taking 1 down, and there is 1 up here. So your entire cluster is upgraded, no downtime, and you could just schedule this up. Hey, run this at this much time.
If one of those fails for whatever reason, does the rolling update stop?
No, it'll try again. So if it is trying to put a 2.0 on one of the nodes, and then the disk fails or the hardware fails, for that it is a failure. Replication controller is here. It makes sure like, hey, I need to have 4 running on 2.0. It'll spin up somewhere else. But at the end, it will find some space where it will give you this picture. Everything upgraded to 2.0. You can go to the site too, right? And it should give you only 2.0 page.
It should.
Yeah. It'll give only 2.0.
So I would imagine that there's also sufficient flexibility to specify that you want to run a couple, like say 30% of your pods at version 2 for some amount of time before you upgrade all of them to version 2.
That is a canary. that we
Canary,
did.
yeah.
The first step, when we spun up one, and then we spun up version 2, another, parallel together. And then we were traffic like 50% go here, 50% traffic go there, like that. And then we validated like version 2 is good. And then we came here and upgraded everything.
Okay, yes. Okay, cool. Very cool.
So after that, I think there is, you got to go back to slides, right? And now is the most important slide, that is questions. We haven't had enough questions, right? Any questions? And that is easy, right?
Yeah.
In a staples, everything is easy.
So, what realistically the work in configuration between everything, the orchestration, it looks easy, right? But
That's for DevOps a little bit.
If you want to build your own pipeline, you just go to these URLs. It'll take you, if you have all the hardware with you, it'll take you less than an hour to build this.
Can you do a traditional .NET with this, or would it just be limited to .NET Core?
So on .NET part, Microsoft has recently come into the Docker board. So now Docker is natively supported on Windows 2016, I think. And so you can, in this mix, you can have like, hey, 3 nodes running Linux, I can have 4 nodes running Windows Docker. The only thing is, difference here is, your Linux workload cannot run on Windows nodes, and Windows.NET cannot run on Linux nodes. It'll be like, if you are writing a Windows.NET application, it will run on Windows 2016, which has Docker platform on it. But you can use Kubernetes to manage all of them. You can have mixed clusters.
The best part is for getting to hybrid, right? Anywhere Kubernetes, you can spin up your pods or any of the Google Cloud,
That's right.
Azure, or anywhere.
I can run my data center on 4 Raspberry Pis. If I get more traffic, it's just one hook, one API where I can say like, hey, if all my 4 Pis are finished, go hook it into GCE or Google Cloud or Amazon Cloud and spin up more nodes out there. So 4 here, so you have your small data center here. Anytime your traffic is more, you go there, spin up containers, all workload go there. It's the same. And then when it's done, peak is done, you just, everything shuts down, you come back to your small data center. And next year, you may plan for a bigger data center.
How many Raspberry Pis does Staples run?
That's a really good question. And I'll definitely find out answer. Right now, I have just seen 4 only. There must be some here and there lying around. He has got some Raspberry Pi zeros. I know that.
I have too many people.
Yeah.
All right, now I got a question for you. Going back to the K8s,
Yes.
what was the original mnemonic of that flavor?
Kubernetes.
No.
It's in German
Before-
something where, German word,
before-
right? Master something.
You talk about board, like concept or something?
No, I'm talking
Borg
about
is still there.
history. That's the notion of you take the first letter, the number of letters
Yeah.
in between, and then the last letter.
Yeah.
There have been at least 2 very important ones before K8s.
Yeah, I don't know about that. That'll be a good
You
thing
don't
to
know
No.
Well, son of a gun. I-18N,
Oh.
internationalization,
Yeah.
and there's one more. L10N, localization.
L10N is totally new. I don't think I have even seen that one, but that is new. That's the, yeah, next presentation I'll have.
Now, let me also say,
Yeah.
this was excellent. This
Thank
was
you.
really,
Thank you.
really good.
So another thing is like, generally we do a lot of talking in Providence DevOps. My boss actually manages that, so we go there and we speak. So here, my suggestion is like, let's use Meetup or a Slack channel like that and discuss about what are the new topics anybody wants to learn. If people are more interested in learning more about Docker, how to do Docker, or maybe do a hands-on on Docker. We have got something we have done at different places where like hands-on Docker. So if, just do, Go programming, this programming, any program you write, come here, let's, do from basic, bring your Mac, bring your laptop, we'll install Docker on your system, we'll do hello world in Docker, and then slowly go and you can write your application, put it there, and what we can do is bring all of those containers, everybody's container on my system, and do an application show.
Do
By the end
I
of the
understand correctly that Docker was written in Go?
Yes, that's what got me interested into Golang. So it was like when I started learning about Kubernetes, the Kubernetes was awesome. The first time I saw the demo, I was mind blown, like, really? And then I was like, hey, which language did you write it?
Docker is Go?
Even Docker engine is written in Go. And then I was like, hey, this is Golang. For me, it was all new. So I used to write a lot of Python and stuff like that, but then it was Go. Okay, fine, time to learn Go.
And Nate Finch works for Canonical, and he can talk about Juju, which is another, I believe.
Deployment tool, right?
Oh, yeah.
Okay, well, so the reason I asked about Docker being written in Go, now I would love to come to a session where people talk about some code that implements Docker. So you see both Go and now that we have this discussion, I have a little better concept of what's going on, and I'd like to see the two of them together. I'd like to map how they implemented some of these operations using Go.
There's some good talks from all those videos from GopherCon 2016 up.
Clean up all the Nginx,
Yeah,
otherwise,
don't
yeah,
pass our data.
otherwise it'll not
Is it
start.
clean it down?
Talks about
Yeah,
You shut it down, I guess.
yeah, but first clean it up.
Yeah, I mean,
Delete-
there's no reason
yeah, I see.
why any one of us couldn't give like a basic introduction of Docker and then follow up with that. Okay, now we have Docker up and running, and do like he said, how to hack data, et cetera. And
Okay.
So one thing is, like, if you want to know about Docker and how to Dockerize your applications, we could do it in the next, are we meeting next month, or it's the end of the year now?
So, no, so, I forgot to mention, so December 12th, I think I said earlier, would be the next one. The only reason why today's out of sorts is because next Tuesday is election day. So December 13th would be the next one. So, and this is a great forum to discuss, hey, I'm interested in whatever. I mean, my email is webrat@gmail.com. You can find me at the same thing on Twitter. You can find me on the Gopher Slack, webrat. You'll find me there. Or use the meetup. Type in the comment pod. I usually get the emails. I'll respond right away. I'll take notes as to what people are interested in. So just,
Okay.
and I talk to Yasmin all the time via email, so just jump in, tell us what you're interested in. We'll get something scheduled. I mentioned to her earlier today, I'd like to try to get Bill Kennedy remote. So I know he owes me
At
one.
all. There's only 2 minutes.
So, okay.
Yep.
What about for long-lived data, like a database, for instance?
What?
Long-lived data, something that's not from.
Oh, okay, so, yeah, you want to take that? That's it.
Yeah, I mean, there are some things coming up. I mean, you define a patch sets, or you can also use the shared storage, which goes along with your, big data. But generally, why would you want to do it? What advantage does it give it to you? That's the question you would ask. I mean, a lot of people now started asking, can we do Mongo in the container, Couchbase in the container? But it ultimately come down to, does it really need to be containerized?
So there's two things. One, automation solves everything. And it's like, hey, automate everything. And then it's like, really, should